Hello, my name is Albert Lee, and this Ada Core video will help you get started with GNATbench for Wind River Workbench. GNATbench is a plugin for the Eclipse IDE framework, and it provides a very nice integration with Ada Core's development tools. We have two flavors of GNATbench. One is for vanilla Eclipse, and the other is for Wind River's Workbench IDE. Before we actually get started, let me describe what our setup looks like. Our host system is running Windows 10, and on it, we've installed Wind River's VxWorks 7 development tools. So now let's bring up VxWorks 7. We'll go with the default workspace. We have some target hardware connected to the system via serial and Ethernet connections. The board we're using is a Freescale i-MX6Q Sabre Lite. As you can see in the Wind River Project Explorer, here in the upper left of the screen, we've already built a VxWorks source build, a VSB, and a VxWorks image project, a VIP. We've made the image project available on a local network using TFTP so that the board is able to find it and load it. Now let me apply some power to our board and we can watch it boot in the serial console downstairs. I'd like to point out a couple of things that you can see in the board's boot output. As you can see, we've booted with VxWorks 7. When we configured the VxWorks source build, we enabled multiprocessing so you can see that the OS detects 4 processors. Also in the kernel configuration, we made sure that the network-based debug agents are available and active. Here you could see that we have both an application mode and a stop mode agent running. This allows us to use Wind River's network-based target tools, such as the system viewer and the debugger. Let's take a quick look at the board. We've already created a target connection called IMX6. And we'll hit the connect button. If you pay very close attention, you'll see these small embellishments around this big capital V that describe the state of the target connection. When you see a small green blob on the lower right, you have successfully connected. Now we can use the target drop-down menu to select Open Connection Tools. Once that comes up, we can use the system monitor to take a look at all the things loaded on this target board. Now we'll close Wind River Workbench and install Ada Core's tools. Before recording this demo, we already used GNAT Tracker, which is Ada Core's customer support portal, to download a copy of GNAT Pro for ARM VxWorks 7 and a copy of GNATbench, both for Windows-hosted development. Double-clicking on the GNAT Pro download will invoke the installer. Note that the Install for All Users option is unchecked. If you'd like to make the software available for other accounts, you'll need to exit the installer and invoke it again with administrator privileges, like we're doing here. We'll install GNAT Pro using default settings all the way through. Okay, now that's done. The next step is to install GNATbench. To do that, you'll need to open Wind River Workbench. If you still have Workbench up and running, you should close and restart it so that it can pick up the new Ada Core toolchain that you just installed. Again, we'll go with the default workspace. The VxWorks connection pane is still open. Let me close it. And then we'll go to Help, Install New Software. On the upper right, hit Add to add a repository. Then in the Add Repository pop-up dialog, we'll tell the system to use our GNATbench zip file as a repository. Hit Archive, locate our GNATbench download, and click OK. And now, you'll be presented with a selection of items that were contained in that GNATbench archive. If we were using vanilla Eclipse, we'd choose the first item, but since we're using Wind River's development tools, we'll select one of the other Wind River Workbench options. VxWorks 7 comes with Workbench 4, so we'll select that. Click Next. Click Next again. The license agreement we'll leave as an exercise for you. We'll just agree to it here. And click Finish. During software installation, you will probably need to verify the certificate we used to sign the plugin. Click on the Details button to show information about the certificate. In the General pane, you should verify that the certificate is issued by ACTE-CA. AdaCore maintains an ACT Europe certificate authority to sign our GNATbench releases. In the Details pane, you can check that the certificate is valid from December 13, 2010 through December 10, 2020, that the certificate was issued by ACTE-CA, that the certificate's thumbprint looks like this, beginning with 59E0 and ending with C0E621, and that the public key info field begins with 30, 82, 1, 22, and so on. For more details, you can contact AdaCore support using GNAT Tracker. Now that we're satisfied with this certificate, we'll select the certificate and click OK to continue the installation. And finally, restart Workbench as suggested. To check that GNATbench was properly installed, we can go back to the Help menu, select About Wind River Workbench, and look for AdaCore's A icon. Clicking that icon will display the Workbench features provided by GNATbench. At this point, we have everything we need to get Ada onto our target board. Let's make it say hello. We'll start by creating a VxWorks DKM, or downloadable kernel module, which is the classic, more primitive packaging method for VxWorks application code. DKMs can easily be loaded and unloaded from the system, and they execute in kernel mode. I'll simply call this project Hello. We'll keep this project and all of its artifacts within our workspace, though you could see that there are several other options available as well. And on the next pane, you can make a selection to base your project on another project. The other project can be a source build, an image, or another existing project. Going with our IMX6-VSB source build is good enough for us. The wizard then creates our Hello project and populates it with some basic infrastructure for building a module. It even helpfully creates a DKM.c file, which contains a sample entry point called start, where you could start adding C code for execution. But what we're really interested in is Ada, so the next thing we'll do is to apply an AdaCore integration that allows this project to understand Ada. It's a bit of an odd place, but we'll find our Ada wizard under File, New, Other. Once there, you could expand the Ada folder, select Convert to an Ada project, and click Next. Make sure that you've selected the correct project to convert. Then, you need to select an Ada project to associate with a Workbench project, and there are three options. Use a local GNAT project file can be used if you manually copied an Ada project into your Workbench project directory. Import an external GNAT project file can be used to associate your Workbench project with an Ada project elsewhere in your file system. We're going to use the last option, create a new GNAT project file, which starts us from scratch. After we hit finish, another wizard pops up to get parameters for our new project. We'll stick with hello as the name of our project. We'll also call the main procedure hello. We'll have GNATbench create the file for us. And we'll even have GNATbench insert some Hello World code for us into that new file. On the next page, we can tune how our new GNAT project organizes its contents. We'll go with defaults for now, but for more information, you could read our documentation on GNAT projects. Then we're presented with even more options. For our simple project, going with the defaults will work well. Of course, you could try the other options if you'd like. After the wizard is complete, you'll see additional content in the Workbench project. An entry for the Ada runtime, new directories for Ada sources and objects. In fact, inside the source directory is where you'll find our hello.adb file with your Hello World code. Makefiles that help glue Ada Core's tools with the Workbench builder, and a new GNAT project file hello.gpr. To build this project, right-click on the project name, and in the resulting context menu, select Build Project. We'll generate includes for our project, which is really unnecessary since we're not using C or C++, but it's still harmless. And then rebuild the C and C++ index. Our build proceeds. Then it completes. Now we have a newly built program. Let's try to get it running on our board. If you right-click on Hello, you'll see that the option to run or debug a kernel task is grayed out. This is because we never reconnected the board after we restarted Workbench. So back upstairs, we'll reconnect to our IMX6 and open up the system monitor. Again, right-click on the project, where this time you can run or debug a kernel task. Unless you're doing something fancy, the name of your main subprogram is what you should use as your entry point, in all lowercase. When you click OK, the Workbench builder verifies that your project build is up to date, loads your module onto the board, and runs it. Our Hello World output appears in the Serial Console terminal. One important thing to know about DKMs is that they are never automatically unloaded. Once your program completes, it's important to unload the module. The I command in the VxWorks shell lists all of your tasks, and naturally, we see that hello is no longer running. The module show command in the VxWorks shell lists the modules loaded onto the board. You can use VxWorks shell commands to unload a module, or you can right-click on the module in the system monitor to unload it. And that's enough to get you started with downloadable kernel modules. Another way to package application code was introduced with VxWorks 6, called Real-Time Processes or RTPs. RTPs share some traits with Unix processes, such as having some separation between user space and kernel space. We can create a Hello World RTP as easily as we created a Hello World DKM. Again, we start by creating a Workbench project, this time making it a real-time process application. The only change we'll make is that the new project name will be hello_RTP. We'll base it on a VSB the way we did before. And there, we have a new RTP project with an rtp.c file ready for us to type in. Yet again, we'll immediately go to using a wizard to add Ada to this project. Click on File, New, Other. Select Converts to an Ada project, and follow the same steps we did before. Create a new GNAT project file, call the main program hello, have the wizard type the hello world program for us, go with the defaults, and now you have an RTP project that contains Ada code. To build it, right-click on the project, click Build Project, Generate Includes, rebuild the C/C++ index, and now you have a VxWorks RTP executable. Our board is still connected, so to run this executable, you can right-click on the project and select Run Debug Real-Time Process. With a real-time process, there is no need to manually specify an entry point. Once you hit OK, the program runs and displays output in a new terminal downstairs. And also, with an RTP executable, there is no need to unload anything after the application completes. This is handled automatically. I hope you enjoyed this quick getting started guide to GNATbench. There's a lot more to explore, and we'll have more videos in the future, so stay tuned.